Welcome to Coach Actor's Math. Today we'll be talking about more similar polygons. Again, similar polygons are polygons with same shape but different sizes. So look at example 1. Determine the figures are similar, justify your answer. So as I look at it, I have an angle of 90 and an angle of 37. So I can find my third angle. So 180 minus 90 minus 37 would give me 53 degrees. So this angle right here would be 53 degrees. If I glance over at this triangle, 90 and 53 must make this angle 37. So the first part that I have to know, all angles are congruent. That's true. So the second piece I need to prove is proportional sides. So in proving proportional sides, we always talk about the one on the left being old, the one on the right being new. So I'd say new over old, 12 over 18. I'm going to set that equal to 2 over 3. I'm going to set that equal to 6 over 9. So as I'm looking at it, 12 over 18, divide top and bottom by 6, I get 2 over 3. 2 over 3 is simplified, so I'm going to leave it as 2 over 3. And 6 over 9, divide by 3, end up with 2 over 3. All sides are proportional. Okay. Since all sides are proportional, I can say, yes, these two triangles are similar. Looking down at example number 2. Use the similar figures below to answer the questions that follow. Okay, looking at part A, quadrilateral EFGH is similar. That's the way to say similar. In case you don't remember from last time. To quadrilateral, well, E matched up with A. F matched up with B. G matched up with C. And H matched up with D. It's really important, guys, that those go in that order. Those angles are congruent, and it is important as we talk about similarity that the angles that are congruent match up and correspond with each other when we talk about the similarity statement. Looking at part B, what is their common ratio? Again, talking old to new. That would make this one the new. That would make this one the old. Okay, what is their common ratio? New over old. I'm going to pick a side I know both pieces for. In this case, the two I know about is 2.5 and 10. The new goes on top, so I'd say 2.5 over 10, which is 1 over 4. Common ratio would be 1 to 4 or 1/4. Finding the following values. I can use my common ratio. And the first thing I'm going to do, I'll solve for x. Solve it for x, I'm going to use my common ratio of 1/4 and say 1/4 equals x over 12. Cross multiply, 12 equals 4x, so x would have to equal 3. Doing the same thing for y, I'm going to again use my common ratio, talk about 1/4. Y is right here on our old shape, so it's going to go on the bottom. So I would say 3 over y. So I would say 12 equals 1y. So y is just 12. Looking on at z. Again, common ratio is 1/4. Z is on the new figure, so z is over 5. Z over 5. 4z would equal 5. Divide both sides by 4. I would end up with 1.25 for z. What is the ratio of the perimeters? Hopefully you remember back from the previous lesson, the ratio of the perimeters is the same as the common ratio. It is 1 to 4, or 1/4. How did B and D compare? Hopefully remember those two things are equal. Again, we'll say sides are congruent because they're in different places. When we're talking about measurements or ratios, those measurements or ratios will be equal because they are a quantity. Looking at example number 3, my challenge to you is see how much of this you can complete without me. So at this time, please pause the video and see how much you can do. Welcome back. So as we look at it, quadrilateral ABCD to quadrilateral EFGH. Again, old to new. So this would be my new shape. This would be my old shape based on the directions. Okay, answer the following questions. Compare angle E, complete the following. The measure of angle E. So now it's talking about the measure, which means it doesn't want me to tell it angle A, but I know angle A and angle E would be congruent. So I could call angle E 60. Angle G is 90 degrees. Angle B is congruent to angle F, which would make it 100 degrees. And angle H would be congruent to angle D. Now we don't have it for either shape, but I do know that there are 360 degrees in every quadrilateral, minus 190 minus 250 when I take the other three angles, leaving me with 110 degrees for angle H. So that would mean H and D would both be 110 degrees. Don't forget to go ahead and mark degrees on there so we know what we're talking about. Talking about our sides now, EH, BC, and AB. In order to find those, the first thing I need to do is find a common ratio. My common ratio, I'm going to use this side. I'm going to say 18 over 6, new over old, is 18 divided by 6, which is just 3. Or, because we want to put it in a ratio, 3 over 1. Any number divided by 1 is itself. So, looking at EH, trying to find EH, I'm going to call EHX. Okay, so I'm going to say 3 over 1 equals 3 over 1 equals x over 5. EH would be 15. BC. Looking for BC. I'm going to call BC y. So I'd say 3 over 1 equals 9 over y. Cross multiply that. 3y is 9, or BC is just 3 when you divide by 3. Looking on at AB. AB we'll call Z. So AB goes with 21. We've got 3 over 1 equals 21 over Z. Or 3Z equals 21. Divide by 3. Z would be 7. So looking down below, what is the common ratio from ABCD to EFGH? In order to find those sides, we've already done that. We've said that the common ratio is 3. Looking down at example number 4. The measure of the angles of a triangle are in the ratio of 1 to 2 to 3. Find the measure of the largest angle. Okay, so right now I know I have 3 angles, and they're in a ratio of 1 to 2 to 3. So my trick is to say 1x plus 2x plus 3x. Those 3 angles are the angles of a triangle, which means they add up to or sum to 180 degrees. So we'd say 6x equals 180 degrees. Divide by 6. X is 30 degrees. So each part would be 30 degrees. So 1x, 2x, and 3x should be my angles. So 1x would be 30, 2x would be 60, 3x would be 90 degrees. Now if you look at that, 30, 60, and 90 should sum back up to 180 degrees. So they're asking us to find the largest angle. The largest angle would happen to be 90 degrees. So as you're looking at that, make sure you remember that trick anytime they're talking about an extended ratio. You can take all 3 pieces of an extended ratio in terms of a triangle and their angles and set it equal to 180. If they'd been talking about sides, I would have needed a perimeter. Appreciate you watching and hope you have a great rest of your day.